Now that we've had some practice with scientific notation, we can work with operations with exponents. In our first example, we are going to find the product in scientific notation. So both of the terms that are given in these quantities are written in scientific notation. So when you're looking for the product or multiplying these terms, we could multiply the numerical portions together, 5 multiplied by 2.9, and then we could apply our product rule. That would be 10 to the 11th plus negative 3. So 5 times 2.9 is 14.5, and 10 to the 11 minus 3, that would give us 10 to the 8th. Now notice that 14.5 is not a number between 1 and 10, so we're not quite done. Think about our last lesson. Remember how we talked about where to replace the decimal? We just changed 14.5 to 1.45. We shrunk that number by a factor of 10. So if this portion of the number is shrinking by a factor of 10, the other portion of the number has to be increased by a factor of 10. So the final answer is 1.45 times 10 to the power of 9. Something similar will happen in example 2. 3.6 times 10 to the negative 12 is multiplied by 6 times 10 to the 9th. So looking at the numerical portions, we will multiply 3.6 times 6, and then that will be multiplied by 10 to the negative 12 plus 9. So first we'll multiply 3.6 times 6, and that's 21.6 times 10 to the negative 3. So again, 21.6 is not a number between 1 and 10. So we need to replace the decimal to 0.16. So we shrunk 21 by a factor of 10. So we compensate or balance by adding a factor of 10. So now we'll have times 10 to the negative 2. This is our final answer. Now notice we are allowed to leave exponents negative, and that's because we're writing our answer in scientific notation. So this is an example of a time that negative exponents are allowed. Here are some division problems with scientific notation. So we want to write the quotient in scientific notation. 1.5 times 10 to the negative 8 divided by 2.4 times 10 to the 20th. So with the numerical portion, we'll go ahead and divide these numbers. 1.5 is divided by 2.4, and that gives us 0.625. And we want to collect all our bases of 10 up in the numerator. So no matter if it turns into a positive or a negative, we are moving or shifting all of our bases of 10 to the numerator. So we're going to have a times 10 to the negative 20 in the numerator. So both bases are 10. Negative 8 plus negative 20 would make negative 28. Is 0.625 a number between 1 and 10? The decimal should be placed in between 6 and 2. 6.25 is a number between 1 and 10. But notice this time we did not shrink our number, we increased our number by a factor of 10. So that means to compensate we need to decrease by a factor of 10 on this term. So we'll end up with times 10 to the negative 29. So if we're increasing the value of 0.625 by a factor of 10, we need to decrease this base of 10 by a factor of 10. In the last example, we'll look at the numerical portion here. 3.6 divided by 9 is 0.4. Base of 10 automatically is shifting up, so times 10 to the minus 2. So notice I've got negative 4 added to negative 2, so that's 10 to the minus 6. 0.4 is not between 1 and 10. I really need to move the decimal one place to the right, so that's increasing by a factor of 10. Compensate by decreasing by a factor of 10. So our final answer in scientific notation is 4 times 10 to the negative 7.